Stop for a second and look at this image. This is 3-eye Atlas under the resolution of the Hubble Space Telescope. Not a backyard scope, not ground distortion, Hubble. And the feature we were told might fade? It's still there. The antitail persists. But that's not even the most interesting part. These images were captured on February 14, 2026 by the Hubble Space Telescope using the UV-IS-2 detector and F350 filter. 4 35-second exposures combined. False color processing by Tony Scamato. What this gives us is high-resolution structure inside the inner coma, the region immediately surrounding the nucleus. And at this scale, small asymmetries become meaningful. This is no longer about is there a tail? This is about geometry, dust dynamics, and structure. Let's break down the key feature. An antitail is a dust structure that appears to extend toward the sun. That sounds backwards because material normally streams away from the sun due to radiation pressure. But here's what really happens. Dust particles released into space don't instantly disperse randomly. Many remain confined to the object's orbital plane. When Earth crosses that plane, the dust sheet can appear edge-on. And from our perspective, it can look like a spike pointing sunward. That's the antitail. What matters here is persistence. Under Hubble's resolution, the structure is still coherent. It hasn't blurred into diffused background dust. It hasn't collapsed into random scattering. That means the orbital plane dust sheet remains dense and organized. That's not noise. That's geometry, plus sustained dust distribution. Now focus on the core. The brightness peak, what we call the central condensation, is sharply defined. This is the brightest region of the coma surrounding the true nucleus. It's often referred to as a false nucleus because the real solid body is too small to resolve directly. In this frame, the brightness gradient is steep. That tells us material density is higher near the center, which implies either ongoing activity replenishing dust near the nucleus, or recently released material that hasn't dispersed. In either case, this is not a fading remnant drifting passively. There's structure here. Now look closely at the inner coma. It is not symmetrical. If this were simple, uniform outgassing, the brightness would fall off evenly in all directions. It doesn't. One side is brighter and more extended. The distribution is directional. That usually points to a localized jet, uneven surface activity, or rotation causing variable release patterns. What this really means is that material is not being emitted uniformly. There's anisotropy, directionality. That suggests physical structure on the surface of the nucleus. Individually, each of these features is explainable, but together, persistent antitail, strong central condensation, asymmetric inner coma, that combination indicates sustained and organized dust behavior, not chaotic breakup, not random dispersion. This is controlled by geometry, rotation, and surface physics. And Hubble's resolution removes a lot of ambiguity. We're not guessing based on atmospheric blur. We're looking at space-based clarity. Let's stay grounded. An antitail does not mean something artificial. Asymmetry does not mean something unnatural. Brightness concentration does not mean something exotic. All of these can occur through well-understood dust physics and solar radiation pressure. But here's the key. They must be explained through physics, and the data must match the model. This image gives us constraints. It narrows possibilities. That's how real investigation works. 3-eye Atlas under Hubble is not featureless. The antitail is still there. The central condensation is sharply defined. The inner coma is asymmetric. That's structure. That's geometry. That's active dust behavior under high resolution. Now here's the real question. If the orbital plane dust sheet is still this coherent and the inner coma remains directional, What does that tell us about how stable this object actually is? Is this sustained activity, or are we catching it at a very specific geometric moment? Let me know what you think in the comments. If you're following this story, consider subscribing. I'll keep covering new developments as they come in. This is still unfolding. The next images may change the interpretation.